Good evening, everybody. Welcome to Shop Talk, hosted by the Triangle Area SQL Server Users Group. So tonight we have with us the regular cast and crew. To my right, adjusting her seat, Mala Mahadevan. How you doing, Mala?
Good evening, everyone. I'm doing fine, thank you.
Excellent. And to my beneath, he has no need to adjust his seats. The seats adjust to him. Mike Christensen.
Thanks very much. Hi, everybody.
So, Shop Talk, as normal. You have questions, we sometimes have answers. When you don't have questions, we start talking about stuff. That's the threat, the implicit threat. We just start talking about stuff. And tonight, I do want to lead off. Hello, Salamar, and hello, Rednello. Welcome in. I need to talk about something before I can take any questions, though. So we got to talk about print spoolers. Apparently, print spoolers are a terrible thing that never should have been invented. Start off with the big one. And all this has happened since the last episode of Shop Talk, so it's even kind of still newsy. This is the CERT current activity report for Print Nightmare, which came out on June 30th. Just got a notification from Rackspace on this. Yeah, so Print Nightmare is a big problem. That's a critical score from CERT. And let me see if that was I don't remember if that was a 10 or not. Getting a perfect 10 from CERT is something that you don't normally see. And CERT gave this one an 8.8. So 8.8 is bad enough. Like I said, 10 is what was it? MS08057, I think it was. Basically the one that that bought security testers steak dinners for a decade. And you rarely get a perfect 10 because basically the score is a measure of how dangerous is it, how easy is it to exploit, and how easy is it to expand from what you're doing. Basically, how bad is it once you've exploited. So this one, pretty bad. The attack vector is over a network and is pretty easy to do. So Microsoft put out an emergency update to say, hey, go patch this, and also turn off print spoolers on domain controllers and servers which don't need to print. Which is probably good advice as it is, even without Print Nightmare, but this kind of made it that much more important. But wait, there's more. Because it turns out that about a week later, there is a second print spooler problem. So that link from Bleeping Computer. Guidance on a new Windows print spooler vulnerability. Different from Print Nightmare. This one is not quite as bad as Print Nightmare because I'd have to check to see exactly the reasoning why it's not quite as bad, but you can still get system privileges on a Windows machine. So I believe it was a little bit harder to do. There were some additional restrictions, but you could still do bad things pretty easily enough that it's kind of scary. And so that has its own CERT tickets, its own CVE ticket. 2021 34527. Then got another one. So, mind you, this makes 3 for the month of July. This one is another Windows print spooler bug, and also let me give you another Bleeping Computer link that gives you some additional information. I just have to make sure. Oh, that's actually the same post. Okay, so second one was actually the newest. But basically, there are 3 vulnerabilities. One is remote and local. Another one is remote only, and a third one is local only, where you have to have a device on the network. And once you have the device on the network, you can send up a driver. Essentially, hey, I've got a print server here, and you should install my drivers. And then Windows will happily go and install the drivers because it's a print server. What could possibly go wrong? So at this point, what Microsoft's recommending is shut off print spoolers on all servers that don't need to print. Make sure absolutely print spoolers are not enabled on domain controllers. And this has just been kind of a mess for printers this month. For print spoolers, I should say. Because it's not necessarily the printer's fault, although printers are also kind of awful. If you've ever had to deal with printer firmware, they're pretty bad too. So that is a little bit of fun on print spoolers, what we're having to deal with this month. And a reminder that, you know, every once in a while you get this big burst of activity around some complex area of code that just makes life worse for us all. So that was the major thing that I needed to make sure that we talked about for today, because it is important enough. You know, if you haven't patched your servers yet, please make sure that those servers do get patched. It is pretty doggone important. So important, I needed to use the adjective doggone. Next, since we're talking about security, SQL Server 2016 has reached the point where it is going to be out of mainstream support. It's kind of amazing to think that it's been 5 years since SQL Server 2016 was released. And, well, Microsoft says that they'll do mainstream support for 5 years on a product. And then it moves on to extended support and then no support. So really, yeah, it's crazy. It's crazy. I mean, I still think it's March of 2020, but who knows? So what we get out of this is we're going to get one more service pack for SQL Server, it sounds like. And that service pack will be sometime, and basically that'll be, okay, we're done with mainstream regular updates of SQL Server 2016. There will still be security patches for another, I believe, 3 years. And then it moves to the special kind of support. The kind of support that we saw for SQL Server 2008, where, yeah, if you moved into Azure, then we would provide you some additional support, some security patches, but otherwise, you're not getting new code for SQL Server 2008. Even with being in Azure, I believe it was really that you would get Microsoft support. They would support you, and I'm going to hazard a wild guess, but I would imagine that a lot of the support would be, you should upgrade to the latest version of SQL Server. That would be a good idea. But that may just be me being cynical and I don't know. But 2016 has left mainstream support. Also of interest, SQL Server 2012 is going to leave extended support next year. July of 2022, SQL Server 2012 will no longer be in extended support. So mainstream support, you get regular cumulative updates, you get bug fixes, sometimes you'll get new code developed. If there's a change, for example, to cardinality estimator or to the optimizer or some sort of small feature addition, oftentimes they will backport that to prior editions of SQL Server as well. So something may come in 2019 and could be backported in a CU to 2017, 2016. Well, that's going to stop for 2016. So we've got 2019 and 2017 that are in mainstream support, that are still under active development. Then 2016 enters the extended support period. Extended support essentially says you're not going to get regular updates. You're not going to get regular CUs. You're not going to get a lot of niceties like 2017 and 2019 will continue to get, but you will get security fixes. So if there is a flaw in the code that could be exploited, then you'll get that bug fix. And that lasts for a few years as well. 2012 is in the last year of that. That is a really good link, Rodnello. And what's funny is I have it on my agenda as well. So we're going to talk about that and another survey. You are one step ahead of me. Good job. But let's actually go into that. So there is a link in chat here from Brent Ozar about a survey of SQL Server utilization. And I'm going to share my screen. We're going to try this. Let's see how it works tonight. Because screen sharing and I, during shop talk, don't always get along very well. In part because this screen is a much higher resolution. So every once in a while, Brent puts together a population report of customers who are using his constant care service. And this is the SQL Server version adoption. So of the customer base that he has, this percent of customers are using, or this percent of databases are using this version of SQL Server. And you can see that the 2016 is still the mode that 2016 and earlier make up a pretty large majority of instances of SQL Server. And doing very rough math in my head, I'm going to say it's about 2/3 of instances are on 2016 or earlier, and that 1/3 are on 2017 or 2019. I'm not including Azure SQL Database or Azure SQL Managed Instance in that. Those are a little bit different of products. So just looking at the on-premises and doing the rough math in my head, it's about 2/3 versus 1/3. Now, on this note, it is really important to point out this is not a survey of all SQL Server instances. And in total fairness, Brent is very clear in this as well. And if you go through the comments, there are a couple of people who say things like, wait, nobody's using managed instances? No, that's not saying that. What it's saying is, of the people who use this product, not many are using Azure SQL Managed Instances or Azure SQL Database. In practice, the percentage of databases on Azure SQL Database is a good bit higher than what this survey would indicate. It's important to keep in mind the population of the survey, that this population is not the same thing as the population of all SQL Server users. And really important to keep in mind, because the types of people who would use Brent's product, not necessarily indicative of the broad SQL Server community. You have certain groups of people who, A, know who he is, B, have the authority, the budgetary authority to get this, C, have the need for it. There are a lot of shops where at least one of those three is not going to be true. And as a result, when you miss out on those, you really don't know what instances they're using. If, for example, the companies that we know who he is, but we've got a team of really good data platform professionals, so we don't necessarily need to use his services. And those companies might be using a lot more of 2017 and 2019, which would be lost in this population. At the same time, I can also say that you may have a lot of people who don't know who he is, who don't know anything about the SQL Server community, whose databases are essentially a thing that we installed back in 2010 when we started up the product, and it just runs sitting under a box somewhere, a desk someplace, and it's running SQL Server 2005. Those people also won't be included in this. So we don't know what the net effect is, and I don't want to give you the impression that, oh, well, in reality, it skews a different way. We don't really have a good answer. Microsoft has some telemetry data, so they've probably got a much better answer than we do, but they tend to be very cards to the chest type about exactly what the adoption rates are for different parts of different versions of SQL Server. And along these lines, Steve Stedman has his version of this as well. People who use his SQL Daily Checkup product, same caveats apply. You'd have to know who Steve Stedman is. You'd have to know about his Daily Checkup product. You'd have to be interested in using it and actually do use it and send back details on it. That said, you still see roughly the same high-level figure that the plurality of people using a version of SQL Server are using 2016. Then he's got 2014, then 2017, and still roughly 2/3 of them are using 2016 or earlier, and about 1/3 using 2017 or 2019. It's actually a little bit lower for his people. And part of that may be, well, Steve's product is, if I remember right, his SQL Daily Checkup is a free tool. It's a free tool that you can use, so it may tailor itself toward organizations which don't necessarily have budget to upgrade, don't necessarily have desire to be on the latest version, and he may pick up an audience that's a little bit more 2 steps behind than what Brent would have, who may be closer to the norm. But again, wild speculation. I don't have good information either way. But still, as Bayesians, we can take these 2 pieces of information and update our priors accordingly. And say, basically, there's a whole bunch of organizations still using 2016. When it leaves mainstream support, it's going to be interesting. And I believe that part of why it'll be interesting is that to this point, upgrading to 2017 and 2019 is a little bit of a niche activity. And what I mean by that is there are certain features in 2019 which I think are really useful for certain types of companies. Like if you're dealing with larger data sets, the updates in batch mode processing for 2019 are really good. If you do data virtualization, the updates in Polybase in 2017 are pretty good. But if you are, you might say, a classic SQL Server customer where I just use data that's in a relational database and an application queries that data in the relational database and I just move on with life. And every once in a while I have to tune a query because everything fails. In that case, you might be on 2012 or 2008 R2 and not even think about it. But for all these companies that were on 2016, they moved up there. 2016 was a big release. There were a lot of interesting features that came up. 2017 and 2019 have felt more like medium-sized releases. I mean, 2017, one of the biggest features was, hey, there's support for Linux. And that makes it easier for containers, obviously. But Linux hasn't necessarily been a real winner in the SQL Server utilization space for production servers. 2017 also had polybase updates, and yeah, had a few other things that I think are enticing, but I can see how a lot of organizations just don't really care about them. And 2019 did add a bit more, accelerated database recovery, et cetera, et cetera. But I already talked about batch mode processing, but still, I can see companies saying, we'll stick with 2016 for a while. Anders, who is currently fighting all kinds of problems, not related to print spoolers, has said there has been no worthwhile upgrades since SQL Server 7.
Window function support is pretty good for me anyway.
So I think merry-go-round queries weren't in SQL Server 7, so that's clearly wrong, Anders. In case you don't know, the merry-go-round processing is where this is mostly for warehouses, but let's say you have a query which scans through a very large table. And during the process of scanning through the very large table, another query comes in that wants to scan the very large table. Instead of starting at the beginning at the same page as in memory, that other query essentially starts where the other one begins and then picks up back at the beginning. So if you happen to have a warehouse that is very busy, you don't keep flushing pages out of cache because, say, this very large table, I'm through here, and then the next query starts. It's smart enough to realize, I just pick up over here, and that way I don't have to evict all the pages from cache as this other query is going. That I thought was in 2005, but it was enterprise only. So if you were standard edition, you didn't get that. So Mike, you said you're on 2017?
Yes. Yep.
Yeah,
I was looking at
Oh, go ahead.
I was looking in the wrong place. It was 2012 R2, and I was like, oh, that's the Windows Server.
Yes.
Never mind.
Thankfully, SQL Server only had one really stupidly named version. So we're 2017 for almost all servers, and then 2019 for my team, because my team has to be special.
Well, you're using all the analytic services, all the new ones.
We're using ML services. We're using a fair number of things. Yes, there is definitely more batch mode processing on my team than most. So it kind of works out well. A warehouse in SQL Server 7, though. I understand conceptually it's possible. 2012, 2014, 2017, 2019. 95% of volume on 2017. I think that's going to be probably the norm for what I would say would be advanced companies who are roughly on the edge. 2019 has had so many bugs and problems that a lot of the customers, the say second wave and third wave installers, have had a lot of hesitance about jumping on it. There are those cool features, memory optimized tempdb metadata tables. Again, batch mode processing, accelerated database recovery. There's some nice functionality that's in here, but then there have been several really big, impactful bugs in 2019 that have been a little embarrassing, really. So yeah, I would agree. Until vNext, it's probably going to be 2017 as the landing spot. We don't know when vNext will be. At this point, given that we haven't heard anything public, I would assume that there's not going to be a SQL Server 2021. Normally, we historically have seen about a 6-month period between when this thing was released or when the first CTPs come out, when the first news spreads, and when we see the final version. So it feels like we're probably a little bit too late for a 2021 release. Who knows if it'll be 2022 or not. We don't have any public information about any of that. 2019 is kind of like 2012, to be honest, like a holding version that you go to if you install new stuff, but no reason to upgrade to it. I disagree about that just because 2012 had a lot of new T-SQL syntax changes. The work with window functions, for example, that big expansion there, and it introduced a lot of new components. Availability groups being one of the biggest ones. I think the thing that hurt 2012 for so long was simply the fact that that was the year they changed the licensing on SQL Server. So now you had to pay more money to get your SQL servers licensed, and as a result, SQL Server 2008 was the most popular version up until, what, 4 years ago? Nobody upgrades their SQL Server after the fact.
Did I check these?
So you've got a couple of 2012 books right here, Mike.
Should I keep them? Should I keep them in extended support on my shelf?
I would say so. You know, the T-SQL language has changed some, but still fundamentally the same. There are extra things that have been added, string split, string ag, that kind of thing. Things like hash bytes have a different set of possible properties, but for the most part, there aren't very many radical changes in the language. At least radical modifications. There can be radical additions, but very rarely do we see an update to code or a removal of functionality that was there.
Right.
So Andrew says, actually, I think SQL Server 2000 was the most popular up until about 5 years ago. There are very few lines of code in SQL 7 that would not run on SQL Server 2019. Yeah, it's one of the things that Microsoft has historically been really good about, backward compatibility. And that ends up with very large code bases that can cause problems because, well, think about every driver issue you've ever had and the fact that this new version of Windows has to support some scanner driver from 35 years ago written overnight by a crew of people who barely knew how to program. And it has to still be able to support that because otherwise people complain that my scanner doesn't work. Windows is broken. And that's a mild exaggeration, but not by that much. I mean, we still have the compatibility layer to allow for 16-bit code to execute. Non-ANSI outer joins no longer work. That's probably, yeah, and that was, remember, that happened in 2008.
Oh, totally.
They finally removed it. No, they removed it a long while ago. Yeah, it was deprecated with 7. I think it was actually removed in SQL Server 2008. But you haven't seen much removed since 2008.
I think I can do pluses and minuses in Oracle.
Those are the asterisk equals.
I think I can still do them.
You can still do equals. You can do inner join, but outer joins, the Oracle style or the non-ANSI outer join syntax, stopped working in SQL Server. And I'm glad for that. You can't do asterisk equal or equal asterisk. Yeah. I'm happy for that. That was an abomination, a blight upon humanity, needed to be destroyed. So good job, T-SQL team. But yeah, since then, very little has changed. And that's the one thing about SQL Server 7. It was early enough that you still had the left outer join syntax, but I would imagine that probably a lot of people still used the old pre-ANSI join syntax style. And that would probably be your single biggest change that you'd have to think about. I spent 6 months getting that out of T-SQL and C++ code. Yeah, it's
Gotta
a
earn
bad
money
idea from the
somehow.
beginning. So, Mike, to answer your question, keep the books. They're still quite useful. Even, I would say, they may only be 90% useful now as opposed to 100% useful. But 90% useful is still going to get you a very long way. And the rest of it is simply what has been added since then. Maybe text pointer stuff. Not sure if that still works. Yeah, you're talking some of the more extreme end. And then we start talking about things like ASMX web proxies on SQL Server, which was in 2005 and I believe was removed from 2008. Again, 2008 being one of the last versions where things were actively removed. Not that many people care, Solomon says, but there was no collate cause in SQL Server 7, or named collations, or different collations for databases, or columns or expressions. Just one big happy global collation in SQL Server 7. It was the Tower of Babel, and then somebody knocked it down, and now we have all these different collations. So we got that going for us, I guess. But now you can have different emoji as database names. I should create a SQL Server 7 database and restore to a 2019 instance. I think because of compatibility levels, you'd have to go something like 7 to 2005 to 2000. You might go to 2008 and then 2012 and then 16 and then 19. You may be able to go 7 to 2008 and skip a step, but you're definitely not going to be able to go in one fell swoop. The minimum compatibility level has increased over time, and as a result, you do have to have those intermediary additions. But what'd you learn, Mike?
I was looking up cross apply and outer apply, but I was looking at the administering databases, not the querying one.
Yep, that'll do it. Yeah, the querying databases, that exam guide was written by Itzik Ben-Gan, and I think he even had a really good section on cross apply and outer apply. Even in that book, where you were going to get 55 questions on XML and 2 questions on anything else related to SQL Server if you take the exam.
Exactly. I reviewed your cross apply presentation this weekend. It was excellent.
Good.
I do it on board.
And that's why Mike gets to be on the program. Solomon says, to be fair, you could have emoji or supplementary character name databases in SQL Server 7. I'm almost done with a post proving it. I do look forward to reading that post and never, ever doing the thing that you're going to do, Solomon.
Not do list is coming up again.
Yep, that is definitely on the not to do list. But I appreciate that somebody is willing to do it just for the sake of trying. And speaking of doing stuff just for the sake of trying, the other topic I want to hit tonight, since we've got some time, is a little bit on reinforcement learning. So let me share my screen again. There was a blog post by Andrej Karpathy roughly 5 years ago, just over 5 years ago. Let me drop a link to that. And it is all about reinforcement learning and essentially training a machine to play Pong. The post itself is written from the standpoint of somebody who has a decent knowledge of computer science, not necessarily a huge amount of knowledge in neural networks, but gives you a high-level feeling as well as a lot of links to get much deeper into the process. In this, he also had some code. So here's the GitHub gist that he put together a few years ago. And it uses a product called OpenAI Gym. And OpenAI Gym allows you to set up a reinforcement learning workspace, essentially. One of the plugins for this allows you to play Atari games, like Atari 2600. And one of the games you can play is Pong. And it turns out Pong is a pretty easy game to train for reinforcement learning. Because at an extremely high level, and we're talking, I'm not going to teach you anything about reinforcement learning tonight. At this extremely high level, you have an agent. This agent, which is the computer program, will have some set of actions to take. When you think about Pong, you have two actions. Move the paddle up, move the paddle down. Technically, there is a third action, which is don't do anything. But for the sake of simplicity, just imagine you just have those two actions. Move the paddle up, move the paddle down. And you also need to have some sort of scoring mechanism, some reward function. And for Pong, that's really easy. You move your paddle up and down, the ball bounces around. If the ball gets past you, your opponent gets a point. If you get the ball past your opponent, you get a point. Which means that each round here has a discrete end. The ball has gotten past one of the two players, and an easy way of determining what that end was. And so we can, given those inputs and the actions that lead to a reward, we can train an agent that has never seen Pong before, does not understand the concept of Pong, can't think about it in a philosophical term, can't think about it, can't learn as a human might the mechanics of it. Instead, they understand the reward function based off of a set of actions that have been taken over some point in time, and over a long enough period of time, gain enough information to hopefully be able to defeat a computer. This particular gist was written, again, about 5 years ago, and it was written for Python 2.0, or Python 2. I've got an update that I just put in place where I made it work for Python 3. That way, if you have a new installation of Python, the code as Andre wrote it will not work, mostly because there were a few small changes. For example, the xrange function has been removed from Python as of version 3, replaced with a couple of methods. The easiest one is used a range function. There are better ways of doing it, but I went with the easiest, most convenient answer. Also, little things like the print function, the way the print operation works, has changed. And things along those lines. We can walk through a little bit of the code right here, just to get a feeling for how it all works. But again, I'm certainly not going to be able to give you a convincing lecture on reinforcement learning. That's not what we're here for. We're here to watch a little bit, have a little bit of fun.
Can I get my money back then?
No refunds. Did you not see the sign? So we have a couple of parameters that we can modify ourselves in order to help the agent learn better, or possibly help it learn a lot worse. The learning rate and the discount factor and the decay rate. Learning rate, important because, oh, I got a point here, so I want to bump up these activities. Oh, I lost a point, so I want to bump down these activities. So you could think of it as, if the ball is above you, move the paddle up, which seems like it makes sense until the ball bounces and then eventually gets below you. So now I have to figure out, well, if the ball is at this angle and moves up to here, then actually move the paddle down. And as a human, intuitively, we begin to understand this as we play the game. As a machine, it kind of has to work into this understanding. And also, you may get stuck in a corner where I have learned something that is actually wrong, but I believe that it is correct. It just happened to be a good answer at the time, but it's kind of got me stuck. I can't get any better because I've learned this thing which is actually wrong. That's where decay rate comes into play, where you purposefully forget some things in the hopes that it gets you out of a local maximum. So it may nudge you along to a path that is actually better in net. And the code itself is only about 100 or so lines. There are a few functions for performing operations, backpropagation, and understanding the results, calculating the results, as well as recording what has actually happened. So understanding what the end result is, what the reward looks like. Was it a positive outcome? Was it a negative outcome? And we keep track of that in our console. So if I kick this off, I have also enabled the view for the rendering version of this, which means that I'm going to need to move it over here so you can see it. But here is what we've got. I don't know how well this is going to show up on screen. Hopefully it shows up reasonably well. And here's what I'll do to make it easier to see that. I'm going to share a specific window. So Anders asks, why is this not in F#? Good question. I'm also going to switch this over to development, by the way. That way, if you're on the Twitch stream, you're going to see much better just how frenetic this is. And like I said, for the reinforcement learning example here, basically staying still was not an option. It constantly has to move up or down. And we can see that it is probably not going to win this game. Turns out that beating the computer at Pong is possible. It's certainly possible. And the trick to it is that you actually want to move the paddle so that you're hitting the ball with the very edge of the paddle so that it bounces. It kind of has the highest vertical bounce rate. And when the game is able to do that, when the agent is able to do that successfully, that's when they tend to get the most points. But that is also a higher risk activity, so the ball is more likely to get past the player, which means that now that this is trained to the level it has, these tend to be fairly high scoring games. So I'm going to stop sharing that. I'm going to come back to whereby. And the other thing, I'm going to keep it running for just a little bit, but what you're able to see if I use my CSI enhancer is that each game we track. We track the you won, you lost, you won, you lost, and so the first game that we saw them play, the computer beat my guy by 7 points. I'm at a point here where, as a result of training this, as a result of playing this, the agent can win probably about a third of games. On net, they lose. The average is a loss by about 5. And wait, is this computer versus computer? Yeah, this is computer versus computer. The agent that I've created, which admittedly, again, that this is Andrei Karpathy's code originally. I didn't really come up with much of it. I just updated it to Python 3. Karpathy's code creates an agent that plays this game of Pong and actually just won the game. So if there's a positive reward total, that means a player won the game. And the computer played the computer successfully beat the computer. So Anders asked, why is this not an F sharp? That may be a fun project, but I'm learning about reinforcement learning, so I don't know nearly enough about it to be able to do something that interesting yet, especially in a different language. Python is the language of reinforcement learning generally. It's where you're going to see a lot of code examples, just the way that it is. Solomon says, the learning things that are untrue part sounds a lot like politics. Yes. That's as far as I'm going. Mike says, as a controls engineer who's written PID loops and more exotic feedback loops, I wonder what was the feedback telling the completely unsupervised learning that it's approaching or diverging from its goal. I heard it was just learning for anything different as different allowed the possibility of playing longer, which was the trick to unsupervised learning of arcade games. Is that correct? Still seems difficult. Let me start with the specifics of Pong itself. Even though very little of the code here was about Pong, I mean, really, the concept of reinforcement learning is extremely generic. Given an agent and some actions and a reward function, we want to have mechanisms that allow an agent to try different actions, understand the reward function, and maximize the outcome. So there's no code in here that is specific to Pong, to understanding what I talked about, where if you move the paddle, like based on the way the ball moves, and that you want to move the paddle and hit the ball at an angle so that you get the highest angular velocity, so it bounces a few times and skirts past the opponent's paddle. There's nothing about that in this code base. That is all learned behavior. Now, for the concept of this unsupervised learning, which this is, yeah, I would say that it is. It's unsupervised, but we have a reward function that is very clearly delineated. It can be extremely difficult. And in Karpathy's blog post, he actually points out a couple of other Atari 2600 games that turn out to be really difficult to do with reinforcement learning. Pong is fairly easy because there is a straightforward mechanical understanding between your activity and the likelihood of scoring a point. By contrast, you could think of a game where your goal is to climb up ladders, jump across ledges, grab a key, and then get to a door. Or even something like Donkey Kong, where you have to climb up the ladders, jump across the ledges, avoid the barrels, and as you have to pick up these key items, that's something that reinforcement learning agents have a lot of difficulty with. Because as a human, we see a key, we see a locked door, we say, oh, I must need to use the key to open the door. I've played video games before. But what we end up with is a reinforcement learning agent that doesn't know this is a key. It just sees some pixels. And we haven't given it information on this is a key, this is a door. It turns out these things work together. So it's blindly stumbling around, continuously losing until it accidentally picks up the key and gets to the door, and then suddenly it wins. And yeah, the AI doesn't know about donkeys and ladders and doors and all of this stuff. Absolutely. And that's what makes reinforcement learning really difficult for more interesting video games. So have I seen the video where a grad student teaches an NVIDIA Quadro card through neural net AI preprocessing to play the first level of Super Mario Brothers. Yeah. Super Mario World. And there may have been somebody who did it for the NES version, Super Mario Brothers, but there's one for Super Mario World. Just the first level. And actually, in that GitHub repo, the author points out the first level is actually pretty easy. It's fairly straightforward. You have ledges. You have the classic Mario accompaniments. You can fall off ledges. You can bump into enemies and die, but without a lot of the real difficulties. Even some of the early levels are so difficult to do with reinforcement learning strictly, because there's a stretch where, for example, you have to either jump and land on top of or duck under the cannonballs. And you only have to duck if you are in Super Mario form. If you're in Small Mario form, you can just run right under. But the problem here is that the agent in level 1 figures out that my best strategy is essentially just do spin jumps throughout the entire level. And if I spin jump in the right ways, then I'm going to get a score and we'll actually be able to pass the level. But that strategy performs really poorly as soon as you introduce this new thing that will defeat the spin jump. So that's trickiness. This is the kind of trickiness you get into with reinforcement learning, where your agents are really, really dumb. And when your agents are that dumb, it becomes painful to have to watch them evolve, because it takes so many iterations. Like this, I've been running this for a weekend. And I've probably had this play somewhere in the order of, at this point, 5,000, 6,000 separate games of Pong. And the game of Pong doesn't end until one player gets to 21 points. So even though this says game finished, that's really just, I would call that a round as opposed to a game. He calls them episodes and games. I would say games and rounds. But regardless of what you say, 6,000 episodes over the course of a weekend, and it's still going to lose more often than it wins. I would probably have to train it for a good while longer for it to get to the point where it is very consistently winning. And that's for a straightforward mechanical game like Pong. Once you start introducing more nuance in the way that the mechanics work, it gets harder. Now, since I mentioned Super Mario World, and I believe that one was called Mar.io, there's another one called Mariflow, which was playing Super Mario Kart. Or Mario Kart for the Super Nintendo. That's what it was. And in that case, it was kind of a reinforcement learning with user input. So the developer was playing Mario Kart levels, went through, did several hours of essentially training the model that way, and handed off to the AI to learn more. But every once in a while, the AI would, for example, get stuck in a corner. And so he goes and gets the controller out and gets the cart out of the corner so that it can go on. And eventually it learns not to get stuck in the corner. But it can take a while. And where you have a human or a trained agent who is more competent at it than your untrained reinforcement agent, you can bootstrap that knowledge. You can really give it a major boost. But if you're starting from scratch, where all I'm going to give you is you have these controls, and you get to see the screen, the pixels on the screen, it's going to take a lot of time to get from that point to really understanding and beating a game. And so, yeah, game theory being is definitely an interesting topic. You know, we can talk all day about subtree perfect Nash equilibria. Look at that. I mentioned subgame perfect Nash equilibria. Excuse me. And we get a follower. That's the way we roll here. So yeah, that's kind of an interesting concept, I think. I was just having fun with it this weekend. Figured, well, might as well bring it up on Shop Talk, and we'll see if our Pong player can finally beat the computer. But if you want to try out that code, I've got a link here in the chat, and we'll also have a blog post coming out tomorrow to give another link and show off a little bit of the gist and get a feeling for what's going on. But if you want to learn more about reinforcement learning, Karpathy's blog post is a really good start. Give some examples, give some links to additional resources. Oh, we just lost. That's a shame. I have to drop a nuke in here. The tech that went into cruise control in cars came from nuclear power plants. Spent 20 plus years in an approval process before it was on the highway. Fast forward to 2015, we just let Teslas drive themselves on the road. Speaking of AI learning. I saw a Twitter thread from somebody who was trying out the self-driving functionality on Teslas and was pointing out these are the places where I had to take back control from the vehicle because it was going to run me off the road. Like, it kept trying to run onto the monorail track in Vegas. It tried to drive into the bus lane instead of staying in the right lane. It saw that there was another lane here, so it's like, okay, I'm going to move over to it, but you're not allowed to drive there. You got to stay in this lane. It made some wide turns that would have ended up hitting trees, hitting planters. So, yeah, it is by no means perfect. There's a lot of work that's been done in the area, and I'm interested in how self-driving can improve, but I think I'm not a big fan of self-driving vehicles at this point in time. I think there is a lot of research and a lot of development that still has to happen before they're at a point where I would say that they're more trustworthy than humans. And considering that humans are terrible drivers, like Salamar points out here, considering that humans are terrible drivers, that's saying something. But humans also have an ability to understand, and when we get confused, most of us slow down, which is very helpful, because if you hit something at 10 miles an hour, that's a lot better than hitting it at 80. The bar isn't really high, although I think... I don't know. I don't think... I think self-driving cars probably would have fewer deaths per year, but I believe that they would be more gruesome. And a lot of those deaths tend to be people who shouldn't be driving in the first place. They're falling asleep on the road. They're inebriated. They're constricted in some manner, which makes it so that they are not in a proper condition to drive. And you have just some terrible drivers to begin with. So, yeah, I get the point. I understand that part. But there's some sketchiness in what is currently available in self-driving capabilities, and I think that it's overblown to an extent. Self-driving on a highway during clear conditions during a day, usually not too bad. But I believe that one of the biggest problems is that basically we can easily self-drive in the conditions where it requires the least amount of human thought and effort. But if you're going to say that the human is ultimately responsible, that the human has to course correct, then we can't just sit back and relax, because humans can't respond that quickly. If I'm driving, if I know that it's tense conditions, like it's pouring down rain or there's snow on the road, and I need to remain in control, then I'm going to have a certain level of focus. But that's a level of focus you can't have for too long. You just mentally can't have it. So what ends up happening is, especially when you don't have anything to do, you have sort of guard syndrome, where I have nothing to do when observing the road. So maybe for the first 20 minutes, I'm going to still be hyper vigilant like I would when I am driving. But after 20 minutes or so, when I've just got nothing, I kick back and get on the phone or read a book or something. And if I'm suddenly in a situation where I need to take control of the wheel because this AI is going to run me off a cliff because it thinks that there's still a road here. Yeah, it listens to podcasts. Yeah. Although the parts of the brain that are important for listening and the parts of the brain that are important for seeing aren't fully overlapping, so that's not quite as bad. Even having a conversation on the phone, that's the thing where as the situation gets more tense, naturally you just kind of stop talking and stop paying attention to the phone and focus more on this. But yeah, if you're engrossed in the podcast and suddenly somebody jumps in front of the car and the vehicle doesn't recognize that, if it's your responsibility to stop the vehicle, move the vehicle out of the way, do something, humans aren't going to be able to do that. I mean, that's the part where I wish that we had smart enough vehicles that could very easily say, "Oh, you're in this bad situation, and we can react faster than you." But the reactions that are chosen aren't necessarily the right ones. And of course, it's also true with humans. Yeah, that Arizona case was the one that I was obliquely referencing, with somebody jumping in front of the vehicle. The lawyer's answer was classic. According to EULA, you were not utilizing the tech correctly. Last comment tonight. I sincerely wish that some judge somewhere would find EULAs just non-enforceable across the board. I mean, they've been a joke for literally decades. Nobody reads them because it's dozens of pages of legalese that are of questionable enforceability to begin with. If you get down to it, some of the stricter provisions in end user license agreements are not legally enforceable. And if you went to court about it, I'm gonna say, yeah, there's no consideration. I mean, that's a factor. Yes, the fact that it's basically, yep, hit that radio button and we install, or hit that next button and now you agree to give your newborn child to us. I didn't select the box. It was my AI. There you go. I think that's the best way to close this episode of Shop Talk. Blame the EULA agreements on the AI. Is she friends with merry-go-round? I got that joke, Mike. So let's wrap up Shop Talk. Mike, say goodnight, everybody.
Good night, everybody.
And we'll see you next time. So take care.
Have a good one.